recording to the cloud. I don't know where it's going. Hopefully Liz can find it. So hopefully we will have a recording eventually for those who weren't able to make it, but would still like to hear the talk or listen to the talk. So just a few little announcements coming up. This Friday, there's still a few seats available for the field trip to Scott Mountain. This is an all-day field trip with Jim James and Linda Wentz. Some other things coming up here soon is a beginner bird walk in Marianne Williams Park on the... Oh, sorry, that one already happened. Never mind. There's an accessible birding coming up this Saturday at Catherine Albertson Park. There's a few slots still at that. The Wednesday Birders will also be at Catherine Albertson Park on the 10th. Few slots open for that. And then we got our Pause, Look, and Listen here on Saturday, July 13th. So you're welcome to do that. We also have some volunteer opportunities. One is to help out pulling weeds at the Warm Springs Pollinator Garden on July 9th. So that would be, well, that happened already, sorry. No, it didn't. That's next Tuesday. And then on Saturdays, some help in watering the plants in the Boise River Rewild would be appreciated. You can sign up. Hopefully you got the news from the nest, and there's links towards the bottom of that to talk about that, or to allow you to register. And then we do have a class coming up here on July 17th, Hummingbirds of the Treasure Valley at the Caldwell Public Library, and that will start at 6:30. So welcome everybody. Glad you could make it. Hopefully everybody is a member of Golden Eagle Audubon. If you're not, please join. Just be aware that if you join the National Audubon Society, the Golden Eagle Audubon doesn't really get anything from them for that. You get the magazine. They say you're a member of Golden Eagle, but it does not support Golden Eagle directly. So please consider donating to Golden Eagle directly and joining directly. It's only $25 a year for an individual. So anyway, I would like to introduce our speaker tonight. This is Zoe Bonerbo. Did I say that right?
Yep, you got it perfect.
Okay. She's going to talk to us about the Prairie Falcon work that's going on there in the Snake River Birds of Prey. So Zoe is a grad student, I think, at Boise State University as part of their Raptor program. So take it away, Zoe.
Thank you, Louisa. I'm gonna try to share my screen here. There we go. Can you guys see that okay?
Yes.
Is there any? Awesome. Okay, great. Thank you for the confirmation. All right. So thank you for the introduction. I am going to be talking to you guys today about prairie falcons and some of the research that is being conducted here in Southwest Idaho. So I recognize a number of you, a number of the names in the audience. Thank you all for coming out tonight. I'm really grateful for those who have tuned in. I kind of fell into prairie falcons, both unexpectedly and wonderfully. They have become very dear to me over the last few years, and I do want to talk a bit about why and how I got here first, before we dive in. So, I am originally from the East Coast, from New York City of all places, and I didn't start birding until I got to college. I went to college in Montreal, Canada, actually, and I graduated with a Bachelor's of Science in Environmental and Wildlife Biology from McGill University. While in undergrad, I volunteered at a songbird banding station that they had there, and that is how I fell in love with the field of ornithology. After graduation, I then went on to do seasonal field work across North America, primarily working with birds and birds of prey. And then in 2022, I landed here in Boise, accepting a position as a lab and research manager for Dr. Jen Cruz in the quantitative conservation lab, which is a part of the Raptor Research Center here at Boise State. And so as part of my responsibilities as a lab manager, and research manager, I assisted on a number of projects that were happening in Idaho here. And one of them happened to be work that was being conducted with prairie falcons. And so this past semester, I began my master's as a master's of raptor biology student in the quantitative conservation lab, stuck with the same lab. And I am looking at prairie falcons as my study species. So jumping into it, a bit of an outline for today. We are going to be talking initially about prairie falcon identification and natural history. And then I want to bring that natural history into context with the population here in Idaho. We'll then dive into a bit more detail about current and former research. Again, bringing in that knowledge of natural history and setting to understand a bit about what's being explored. There will be time for questions at the end as well. You may see at the bottom of the screen certain citations, and so those are basically if anyone wants further information on the topic, you feel free to jot down that information so you can explore a bit more on your own time. All right, so jumping in. Prairie falcons are a medium-sized bird of prey. We call those raptors. So birds of prey are also raptors. They are a falcon species. So in North America, we have a number of falcon species. A few of the others include peregrine falcons, which are very well known, kestrels, merlins, gyrfalcons. Prairie falcons are slightly smaller on average than a peregrine falcon. A rough estimate of size would be around a crow, a small crow. Though there's a little bit of, that's a very rough estimate. So falcons are raptors in the family Falconidae and the order Falconiformes. So the term raptor is not actually a scientific classification though, nor is the term bird of prey. Falcons are actually more closely related to parrots and to songbirds than they are to other raptor species. So you see this grouping over here on the figure to the right. Coming over to the left side of this figure, you see the accipitriforms. This includes eagles, hawks, vultures, kites. And these birds of prey are next to the strigiforms, which are our owls. And so these birds of prey, looking at this taxonomic tree, diverged earlier in time than the falcon clade, which diverged more recently to us. They didn't evolve until more recently. So what makes a raptor if it's not an actual scientific grouping? Well, there's a few key features. One is their ability to hunt and kill prey with their feet. So they have really large talons that they use in order to hunt. The next is their sharp curved bill. And falcons actually have a very unique feature, which is called the tomial tooth, which is a second tiny little ridge on the beak that is used to break spinal cords, actually, for cervical dislocation, in order to not only take out their prey with their feet, but to make sure that the job is done at the end. And then lastly is their keen eyesight and these forward-facing eyes that are a part of all raptor species that we call raptors. So a little bit more about prairie falcons, though, in specific. Coming over to identification, there are two specific features that are common traits in most falcons. The first being these long pointed wings. They're very thin and narrow, and they come to a V shape at the end. This is what allows falcons to gain those speeds that they're known for. So the prairie falcon, notably the fastest bird on the planet, although I think if we timed a prairie falcon, it'd probably be pretty close. They just don't tend to stoop as much as peregrine falcons. So I think they could probably give them a run for their money though. But these long pointed wings are classic. We also have this thin malar stripe. So with different falcon species, this malar stripe can be different widths. It can be stronger, it can be bolder, it can be larger. For prairie falcons, we see that there's just kind of this one thinner stripe on their face. A few other key identifiers for prairie falcons are these dark armpits. So when they are flying, if you see a dark section between the wing, where the wing meets the body, that's a key identifying factor, as well as a light brown and white body, chest, and face. So for example, in comparison to a peregrine falcon, peregrines are going to have much darker slate blue-gray feathers, while you see this overall brown warm tone to the prairie falcon that has this large contrast with the area where the wing meets the body. They can also be identified by their distinctive calls. So you'll oftentimes actually hear a prairie falcon before you see them. I do have a call embedded. It was not working earlier, unfortunately, but you can look it up on the Birds of the World on Cornell Lab of Ornithology or YouTube. You can hear their calls. It's a very loud, we call it a cacking sound, and it is used for communication as well as defense. So to scare off any other birds that might be in the area. And it sounds a lot like a high-pitched wailing, essentially. So continuing on, where do we find these birds? So most of these birds are in Western North America and Central America. So they span from southern Canada up here through the Americas and down into northern and central Mexico. Most of the time they occur throughout most of the range of the West. This is their year-round range in purple. And then they do expand their range in the winter. So they're going further to the east and further south in the winter time, in the winter months. In terms of habitat, within the West, they inhabit desert and grassland ecosystems, areas that have very wide expanses, and they primarily use these areas for hunting and foraging. Within these open landscapes, they also require cliff faces, and they use these to nest and roost. So looking at this photo, you see rocks with a lot of little cavities on it. And you also see these tiny little spots of white. That's actually all bird poop. So we call it affectionately whitewash. And so these cliff faces are not just supporting prairie falcons, but they're supporting a wide range of cliff nesting birds. This includes great horned owls, golden eagles, red-tailed hawks, ravens. There are rock pigeons, cliff swallows, plenty more. And so they use these little spots as perches and as ledges to roost on. And occasionally they'll also use it for nesting. So all the way over here on the left is a ledge that they actually used to nest on. So there was a family of prairie falcons here, and you'll see a few photos of that a little bit later in the presentation. And so this is how you can tell that there are birds in the area. If you see a lot of these markings of whitewash, it's a good indicator. So this is an example of what we look for when we are out in the areas that we're surveying. We are scanning with binoculars and scopes to try to find these little tiny cavities in which they are hiding and potentially nesting. So I'm going to show you guys two different photos. Here we go. Of nesting prairie falcons. Now we see two different strategies. Prairie falcons actually don't build their own nests in a classical sense when we think of those cup nests that a lot of birds build. They will either take over one that has already been built by another bird, so by by ravens or golden eagles. Red-tailed hawks as well will build them on cliff faces. And so they'll either take over one that's not in use, and you can see a lot of stick matter here in this photo on the right where they did that. Or if that's not available or not an option, or if they just have a personal preference, they will lay their eggs directly on the rock face. The only thing they have to be worried about here is the eggs potentially rolling off. So they'll put a little bit of matter around it so that it doesn't actually roll off of the rocks. And then they will just incubate them directly on the rocks there. So looking at this photo here, you can see 5 eggs, which is a pretty average clutch size for prairie falcons. It does range anywhere on average between 3 to 6. There have been cases of more than that and less than that, but it's pretty classical to find anywhere between 3 and 6 eggs laid, with 5 being pretty common. The whole breeding season lasts from approximately March through July. So courtship begins and the selection of a nesting cavity begins in March. They'll lay eggs in late March, early April, and then young will be fledged by June into July. So I'll show you a few examples going through all of those stages. But I do also want to mention that the male and female do tend the nest together. The female is the one that is primarily responsible for incubation, but the male will incubate as well. However, the male's primary duties are bringing food to the female while she's incubating. So he's also out hunting for food for both of them. So this is an example of both a female and a male on a nest. We do call the nests scrapes. So if I show you guys the photo from before, I don't know if it'll let me. There we go. We do also call them scrapes since they're not actually building their own nest, classical nest made of sticks and debris. We do use the term scrape. If you hear me calling it that, know that it's referring to a nest. All right, so once the eggs are laid and they have hatched, we have nestlings. So the nestlings are not able to thermoregulate until about 11 days of age, which means that they're being brooded. They still need to be incubated up until then, and they're being fed and cared for by the parents. So I want to show you a video of nestlings that are approximately 7 days old, and what they look like being fed by the parent. So if you can believe it, there's actually 5 puffballs in that nest. I have many names for them: puffballs, cotton balls. But I can say this is a nest that we monitored this year, and I can say that all 5 successfully fledged. They did use an old golden eagle platform stick nest here. And the adults were very attentive. And so growing up, I'll show you an example of what they look like as they get older. It'll let me, oh, it's just going to replay it. Let's do this. There we go. So as they grow up, they start to develop new capabilities. So in this image, these nestlings are about 17 days old, and they are able to sit up. They are able to support their own heads and their own weight. You can see that they are still entirely white. There's no actual growth. There's just the barest amount of growth of new feathers developing. And they are still very much dependent on their parents for prey to help rip up that prey for them and feed it to them. And then once they start getting older, these guys here, about 25 days old, you can see that their flight feathers are starting to emerge. These are the primaries, secondaries, and tertials, as well as tail feathers that are starting to come out from all of this downy white fluff, but they still have an overall large percentage of baby feathers. In this third photo, These are what they look like right before they're about to fledge. So these birds are 38 days old, and they fledge at about 38 to 40 days, so they're ready to fly at any point now. And you can see that there's no more downy feathers except for a very few little tufts on the top of their head. Now, there's a few distinct characteristics to tell a nestling and fledgling prairie falcon apart from the adults. So the first is to look for this buffy breast coloration. It's very tan in color instead of that nice white with the contrasted brown streaking that we see on the adults. We also have a cere and feet that are gray in color. So the cere is this area of the nose that is right behind the beak, and this and the feet are both grayish in color. On the adult males and females, it will be a yellow to orange color, a brighter color. Males tend to have slightly brighter orange and yellow than females, but this can vary by individual. They also have back feathers that are a little bit darker in color than the adults. And so the way that I like to think of this is almost like looking at dark chocolate versus milk chocolate. So the nestlings have a dark chocolate coloration when you see them flying around on their backs. The adults have more of a little bit of a milk chocolate coloration. And so these feathers will slowly and progressively change out for their adult plumage, and the beak and the feet will slowly gain that yellowish coloration over time. So I want to talk a little bit about diet. We saw an adult feeding her babies. So what are they eating? Well, they are one of the few falcon species that specializes on small mammals. Most falcon species either specialize on birds or they're more of a generalist. They don't have a specialty. And so prairie falcons are pretty unique because they have a very distinct link to ground squirrels, which is one of their favorite food sources. They do supplement with other small mammals and birds and reptiles as well, which we will see a little bit later. I am going to show a few photos of some dead prey items. So if you're grossed out by any dead thing, it'll just be the next 2 slides, and I'll let you know once we're done so that you can look away and then come back. All right, so the first photo, we have here a scrape with several nestlings, as well as both the mom and dad. In the front here, this is a kangaroo rat. So it's a species that's very common in American deserts. And the male here is holding the kangaroo rat, showing it off to the camera. In the background, this female adult is actually already feeding her nestlings a prey item as well, which we believe to be a bird based on some other photos that we had. And so heading more, this is the top half of a ground squirrel. So we have an adult and a nestling that are battling it out. They're not actually battling it out, but the nestling is learning how to rip its own chunks off of the prey item. So the parents aren't directly ripping it off anymore and feeding it to them. The nestling is also learning how to do that for itself. And this is also a great photo that shows an example of that contrast between the yellow behind the beak on the cere, as well as the feet, in contrast to the gray that the nestling has. As well as these back feathers that are very dark chocolatey brown and the milk chocolatey brown of the adult. All right, so the other little quick thing I want to mention about diet is that prairie falcons, and we'll explore this a bit more later, leave their breeding range once nestlings are fledged and their ground squirrels start to disappear. So specifically, ground squirrels go underground when it gets too hot out. They start to hibernate when conditions are too warm. They're very heat sensitive. So prairie falcons will actually travel north to cooler areas, which we'll see a bit more later, starting around mid-July. Because ground squirrels haven't gone underground there yet. It's cooler temperatures. They haven't gone into hibernation. It hasn't gotten as hot. And then throughout the winter, they may come back down south or travel to the east or a little bit to the west and feed on and supplement with birds during the winter, since most mammals at that point are in hibernation. So we talked about what prairie falcons eat. Well, what eats prairie falcons? So naturally, one of the biggest things that we see are great horned owls being a predator. They are a nest predator for a lot of species. They will take chicks and eggs and things like that. Occasionally, other large raptor species may as well, golden eagles. However, prairie falcons overall are a species of least concern, so we're not too worried about them. They are affected by other threats as well that are more anthropogenically caused. So there are 5 main drivers of wildlife decline, and we do see this potentially affecting prairie falcons as well. Habitat destruction, so particularly their foraging areas, the land in which ground squirrels live, and birds and other small mammals being converted and destroyed. We also see pollution. Now, pollution is not just simply air pollution that we think about. It can also be toxins that are in the environment and in their prey sources. So specifically rodenticides, pesticides, and lead. Lead shot is very common out here where I am in Idaho. And prairie falcons can pick up these toxins when they are out foraging for prey species that have picked it up. Climate change. We see deserts and grasslands are actually some of the most affected ecosystems by climate change, as well as invasive species. In this case, oftentimes invasive species that's affecting the vegetation where they forage and hunt, so the areas can no longer support the prey populations that they're trying to eat. And the wildlife trade, which historically there have been issues with prairie falcon eggs being taken illegally from the wild for the falconry industry. So all this being considered, they are still a species of least concern, but we do a lot of research in order to understand how we can conserve and protect these birds in the face of threats. And that does take place here in Idaho. So I want to talk a little bit about why Idaho, why here. So prairie falcons are a focal species here because we host the Snake River Canyon, and the Snake River Canyon contains miles of cliff face, which is prime nesting habitat for a lot of raptor species, including prairie falcons, all along these cliff faces here. It also contains sagebrush steppe and grassland habitats, which support diverse prey species. In Idaho, we have more specifically an area that's called the Morley Nelson Snake River Birds of Prey National Conservation Area. So that's the area that is outlined here in this orangey tan color. It is about 45 minutes to an hour south of Boise, so pretty close. It's just under 500,000 acres, and it's owned by the BLM, and it is the only national conservation area that has been established to protect birds of prey. It is recognized as having the densest concentration of breeding raptors in the lower 48 states. That includes golden eagles, red-tailed hawks, ferruginous hawks, great horned owls, prairie falcons, barn owls. The list truly goes on and on. It also hosts a military base on it, who we often collaborate with projects for. And then here in Idaho and in the Boise area, we also have the Raptor Research Center here at Boise State, as well as the Peregrine Fund. So it's a big intersection of a lot of raptor researchers in a very small area. Now, intensive studies of prairie falcons have occurred dating back to the 70s, and their findings have helped establish the actual boundaries of the NCA. So their movements, where they were foraging, where they were nesting, all of that was taken into account when establishing these boundaries so that their entire ecosystem, the entire range that they needed, was accounted for and protected. The NCA hosts more than just raptors as well. There's a lot of diversity here, which is really important for a sustainable environment. There are coyotes, badgers, snakes, the top of the food chain as well. We have rabbits and ground squirrels and kangaroo rats, lizards. We also have endangered plant and fish species out here. However, the NCA is a changing landscape. So over the last almost 50 years that it has been established, while it is a conservation area, it has been affected by some of those threats that we were talking about earlier. So specifically the loss of habitat due to development, as well as the spread of invasive species, including cheatgrass and tumble mustard. And so we closely monitor a lot of the birds of prey that are out here to see how these changes could be affecting them and to get ahead of it. So if we're seeing any issues, to be able to address them in time. And I want to talk a little bit about that research that has been happening around prairie falcons. This won't be comprehensive. We can't go into absolutely everything, but I'm hoping to touch base on a few points that I find really interesting and cool. So the two topics that we'll be talking about are demographics, which refers to population characteristics, so the size of the population, births, deaths, things like that. And then we'll also talk about individual variability. So more specifically for this, differences in individual behavior. These are both really important because they relate to a species' ability to be resilient and adapt to a changing environment. So resilience was defined by Dr. Maston at University of Minnesota as the capacity of a dynamic system, in this case, our prairie falcon population, to adapt successfully to challenges that threaten the function, survival, and future development of the system. And I like this definition a lot because I think it accounts for future development, which we often don't think about. So we want to think about sustainability into the future, as well as current survival and function. So how does this relate to prairie falcons? Well, jumping into demographics, with our populations, we do see prairie falcons have fluctuated through time here in the NCA, their population size. The figure that I have up here is a paper published in 1999 by Karen Steenhoff. You can see on the x-axis is the year that they were surveying, so surveys that were conducted in the 70s and 90s. On the y-axis is the number of breeding pairs of falcons that they counted in the NCA. And those numbers of pairs are also written above each bar for each year. Now it averages around about 200 pairs, but you can see that there are these dips in 78 and 94. And the consequences of having a dip in the number of breeding pairs is that there's likely less eggs laid across the population, as well as less babies hatched that year to contribute to the population size. So fewer births overall. This graph does not include more recent data, but there were surveys conducted in 2019 through 2021, and they did count approximately 250 to 300 breeding pairs. This data is currently in prep to be published. And we do see what's good about this is that even when they have these dips, they are coming back and rebounding from it. They are not in a steady decline. And so it's important to understand this demography because if they were in a steady decline, then they wouldn't have a whole lot of resilience. They wouldn't be adapting to any changes that were occurring. But when you see stability or a population increase, then we do see resilience. We do see that to some degree they are able to adapt to the conditions occurring in the NCA. And overall, this helps inform us about the growth of the species overall and in what state they're at. So we want to keep them in a state of least concern. Now, continuing into individual behavior, what might make them resilient to a large decline? What might make them resilient or adaptable to changes? Well, this is a relatively newer field of exploration in the scientific community, but essentially demography, which we just said was the population size, survival, births, deaths, things like that, can be mediated by personality differences. And I want to describe a little bit more about what that means with this figure. So essentially, there's a pool of traits that the population may have, and these pool of traits may look differently between individuals. So we have two different traits here, the blues and the greens. So two different, within the same population, two different sets of traits. Looking at this figure, we have time on the x-axis here and different conditions or states along time. So we have just average climate, warm year, and cold year. When we have a combination of two different types of traits, we see that across all of the years, the individual traits respond differently, but the combination of the two means that it stays stable, and it stays at a consistent population size. When we only have a population with blue traits, we see that they do not do well in warm years. So these individuals have a harder time surviving in warmer years, and we see population decline. Now, they do better in colder years, but it's hard to know whether or not, having influenced or experienced a warm year, if they could pick themselves back up again and actually get to this population size the next year. Sometimes there's a lag and a delay, so immediate growth is not always expected. Conversely, this green population does really, really well in warm years, but they don't do so well in cold years. It's really the combination of these traits that allows the population to be persistent over time. And I want to look at this in action for prairie falcons. So our first example is individual variability in their breeding range. So on the left, this outline here is the NCA, this black line. And on the left here, you see a prairie falcon that we recorded nesting here in the NCA in both 2021 and 2022. On the right, there's a bird that nested in 2022 and 2023. And you can see a big difference in the size of the breeding range that they're using. You also see a little bit of difference in the consistency. So this bird was not using as much territory that overlapped between years, while this bird was very much consistently using territory that overlapped between the 2 years. So why do individuals of species have different breeding range sizes? Why are they showing these different patterns? Why is there variability to begin with? Well, individuals may have to deal with different pressures. So some may have more competition in the area than others. Maybe there's a second raptor pair nesting really close by that they're competing with, or a predator in the area that they need to avoid. Maybe there's less food resources in one area, and so an individual has to travel farther to find what they're looking for. We also see quite a bit of variation in movement patterns, similarly. So these are the non-breeding movement patterns of 2 of our birds. This bird over here on the left has traveled from Idaho all the way up to southern Saskatchewan and back over the course of 3 years. So each color here, the blue, the red, and the pink, is 3 different years of travel. This black is the start of a 4th year, so 2024. Little bit of insider information, I can actually tell you that as of this morning, this bird has checked in Montana. So it's actually already left Idaho and has checked in Montana. It's no longer in the breeding area anymore. But jumping back into it, this bird has a very consistent moving pattern year to year. Over on the right here, we have another bird who is nesting here down in Idaho, same in the NCA area that we've been tracking and monitoring. And every year it comes up to Montana and then goes over to South Dakota, and then it has fun coming over to Washington, and then eventually it makes its way back to Idaho. But there is a lot more exploration over here, and a lot more movement, and a lot more inconsistency in its patterns of what routes it's taking and things like that. So these personality differences of an individual who is more consistent and an individual who is more exploratory, those can be potentially tied to other traits as well. We often see animals that are more exploratory may also be a bit more bold. They may have higher aggression levels. Those who are less exploratory could be more shy or cautious. And these differences can benefit them in different situations. So the combination of these traits in a population can be helpful or detrimental in different situations. For example, in a low resource year, an exploratory individual may be better at finding food. If there's less food on the landscape and it's willing to travel further, that may benefit it. And in that case, it's going to increase their chances of survival. Alternatively, in areas where predation risk may be very high, being shy and cautious and less exploratory may have better increased chances of survival. So, and these traits could be both learned or innate. So they could learn them from their parents, or they could potentially already have it coded in their DNA to some degree. However, having both is very important to make sure that we're not seeing population decline or crash. And I want to give one more example of this, which is their individual variability with their diet. So this was a figure put together by one of our undergraduate research techs who went through some of our camera footage that I'll talk a little bit about in a minute. And on the x-axis, there are 4 different territories that we were monitoring. And on the y-axis is the number of prey items that were delivered to that nest for that territory. The reddish-orange color here represents ground squirrels, which we know they love. And ground squirrels made up anywhere from 33% to 79% of their prey deliveries. However, the one that has 33% does have a high proportion of unidentified items as well. So this could be higher. We just simply don't know because we weren't able to identify all of the individual prey items. What's interesting about this is that these findings were actually pretty consistent with findings from the 1990s as well that assessed diet. But we do see variability between the prey, even though they do oftentimes prefer ground squirrels. We do see some that are catching a lot more birds. We see some that are catching reptiles while others are not. Even though it's a small percentage. And so why might there be differences in what they're eating? Well, it could be the areas that they're foraging in, for one. So it could be their part of their breeding range. Their breeding range includes both the foraging areas as well as the nesting area. So it could be where they're foraging. It could also be personal preferences. So the same way that you and I might have different favorite food choices, prairie falcons could as well. It could also be what they're used to hunting and catching. So if any of the fledglings are learning from adults, they could be watching and learning how to catch different food items. But what they eat can absolutely also have demographic consequences. How much food an adult can find and what type of food it's bringing back to the nest can affect how many nestlings they're able to raise and how many survive to fledgling age. So overall, I think it's really interesting and important to recognize that prairie falcons that we're researching here in Idaho, which makes up about 5% of the entire global population, has a lot of variability and a lot of individual personality, which hopefully increases their chance of survival amongst habitat change and other threats that they might face. Their individual personalities also make research really fun to conduct. And I want to talk a little bit about how we actually conduct that research and collect this data to end it. So the first is basic good old-fashioned scopes and binoculars. So this photo was taken through a scope. The video of the adult feeding her nestlings before were taken through a scope. We use these to conduct visual observations, and visual observations have been the foundation and the basis since the 70s for this research. And there have been numerous people who have gone out and taken time to survey prairie falcons. We use it to identify the breeding pairs, to identify the scrape that they're nesting in, to monitor them throughout the season and record things like egg laying dates, hatching dates, how many make it to fledgling age, things like that. And you do really get to know the individual pairs pretty well. Some of them, while you're out watching them, will be a little bit more territorial and react more defensively to you being there. Some of them do not care that you are there at all. And so it's really, really cool to get to see those individual differences. Now we also use transmitters. So all of the movements that you saw before, as well as the breeding ranges, we calculated those through points, GPS points that were collected by these transmitters. There are different types. So these ones specifically are solar transmitters. They were deployed from 2021 to 2023 by a former grad student. These transmitters need to be less than 3% of the body weight of the bird in order to not affect any of their flight or behavior. And that's pretty much standard across the board, not just for prairie falcons. These transmitters are very streamlined on their body, so it's not affecting any of their flow. And they're situated basically like little backpacks. So they have straps that go under the wings and come back up and loop around. They collect GPS points at fixed intervals. And that's what we use to map where the bird has traveled. Lastly, we are also using trail cameras. So these trail cameras help us capture diet and productivity data. So the diets that are being brought back to the nest, the prey deliveries, as well as potential causes of nest failure if the nest does not make it. We have two different models of cameras that we've been testing. They're both motion activated. And so we actually rappel into the nest to install these cameras. They get drilled into the side of the cliff, into the rock, and then they get mounted and face the scrape and the ledge that the nestlings are situated on. And the ideal goal is to capture the span of ledge that they're using, that the parent may be coming and bringing back food on, and that the nestlings are using for protection. So that is the summary of the work that we are doing currently, as well as the research and what we know about prairie falcons right now. I do want to thank a number of people who have been working on prairie falcons for a number of years. Karen Steenhoff, Mike Hokert, Steve Alsop, Todd Katzner, Kevin Warner, Matt Stuber, my current PI and supervisor, Jen Cruz, our undergraduate research technician, Andrew Baker, Eden Rebecca, who is a former grad student on prairie falcons, Kevin Myers in the Julie Heath lab, who have been great with helping us install some of the nesting cameras, as well as all of those who have spent hours contributing to prairie falcon research and monitoring. I want to thank the Idaho National Guard as well. They are big in-kind supporters of this research, Quantitative Conservation Lab and all of its other members, as well as the Raptor Research Center at Boise State University, which is supporting me in my work. And thank you to the Golden Eagle Audubon Society for having me this evening. So if you want to contact me with any information after this, this is my contact information. Up here, you can also follow along on Instagram for updates. And thank you. And I am happy to take any questions that people might have as well.
Hey, Zoe, thank you very much. We do have a couple of questions in the chat. So first of all was, how are the birds captured when a transmitter is installed or changed?
Great question. So there's a number of ways you can do it. The way that was most effective that we saw was we use a taxidermied great horned owl. So because great horned owls are nest predators, a lot of birds really hate them. And so we actually put we call it a robo owl. It has the ability to move its head. It has a mechanical feature inside, so you can move its head, you can move its wings. And you put very large, what are called mist nets around this owl, or some form of mist net. And basically the prairie falcons will swoop on the owl, trying to scare it off. And the goal is to have them swoop on the owl and hit the net. And then we can untangle them from the net and put a transmitter on and release them.
Great, thank you. A couple more here. Do the fledglings stay in the same area to nest or go elsewhere?
That's a great question. So it only takes the nestlings, I didn't mention this before, but it only takes the nestlings about 40 days to fledge, and then they stick around for another 20-ish, 25-ish days after that. So the whole process is really 3 months until they are left by their parents to fend for themselves. And at that time, they will start to disperse a little bit further. There are some great papers looking at the dispersal of fledgling prairie falcons. They do take some time to just explore the general landscape around where they were born before they actually fledge out and go north for the rest of the summer. But it's a pretty quick process overall.
Awesome. A lot of the questions are really telling how great a job you did, so I hope you get a chance to look at them in detail. One other question is, the scrapes seem narrow, unprotected. Do babies fall off the scrapes?
It's a good question. So there is a risk of branching too early. So oftentimes prairie falcons they're very charismatic, and I love them because they start moving around pretty early on in age. They can start walking around the cliff face. Those ledges are narrow, but you'll see them jumping and hopping between different rocks. And so some of them will actually end up on the ground, and the parents will come down and feed them if that's the case. They are very vulnerable when they're on the ground before they're able to fly. It's not always the case that they'll end up down there, but those that do, the parents will still come down and help them and check on them.
Awesome, thank you. We have time for one or two more questions. Louisa, you have any closing thoughts here while we're looking for a last question or two? Here's a question: are prairie falcons monogamous?
Oh, great question. Yes, so they will oftentimes nest with the same individual that they did the previous season. They do not oftentimes winter with them, though, from what we know. So they will meet back in the same territory or area the next year. If their mate is still alive, and they will, yes, they will stick with the same mates for as long as they can.
Great. And then I missed one question here. At what age do you ban the chicks?
Good question. So we don't always ban. We usually will ban them if we're putting in a camera after they are of age where they can thermoregulate. And so in that case, we can put in a camera anywhere after the age of 11 days, but ideal banding age is around 21 days old. Oftentimes we don't band though, because a lot of the cameras that we've installed, or not a lot, but some of the cameras that we've installed, we've put in during mid-incubation. So when they're actually still on eggs. And so prairie falcons are very resilient to that kind of disturbance. Not all species of raptors are, but we can actually go and put the cameras up when they're still on eggs.
Great. And then John and Donna, you have a question that says, how can we see them? I assume that means where and where's the best place to see them or what to look for?
Yeah, if you're here in the Idaho area, going down to one of the great places is, if you know where Dedication Point is, down in the NCA in the Morley Nelson Snake River area, it's south of Kuna. So if you basically just go straight south of Kuna on Swan Falls, you'll make it to an area called Dedication Point. If you continue down that road and you go down to the dam, the Swan Falls Dam, there's actually a lot of prairie falcons that if you just drive that road along Swan Falls Dam up to Swan Falls Trail, there are nesting prairie falcons along that road. So it's a good place to scope them out and look for them and yeah, get out for the day.
Great. And then is this presentation going to be on YouTube? We are recording it, but neither Louisa and I know exactly when that will be available. So stay tuned for more information on that. When Liz gets back, I'm sure she'll be able to tell us how to get to that.
Yeah, I got Dan.
Go
Also,
ahead.
let people know that if they go to Swan Falls Dam, you know, you can cross the dam and start walking along a trail up the river, and along that cliff face, you can find prairie falcon nests as well.
Great, thank you. So, Zoe, this has been awesome. You've had a lot of comments about how informative this is and a great presentation. For all you folks, if you're not members, please join. We could always appreciate your donations to be able to keep making presentations like this. And Louisa, you guys can close it.
All righty. So we kind of pretty well covered it. So like I said, this has been recorded. In fact, I think I'll stop it now. We don't need to listen to me.